Hi, welcome back. We just finished 6 and we got our answer 80. So let's pick up with 7. Now 7, I'd like to give you a technique. It says if A and B are positive even integers, which of the following would be greatest? Okay. So I already wrote down my answers. Here's my answer. So if you got that, you were right. Let's see, what would be one way to be sure? So positive even integers, we could substitute in 2. That's a positive and even integer. And we could also substitute 2 in for B. And we look through here and we say, okay, A is going to be one of the numbers, or constants, we call those, the number that's going to stay the same. B is going to be the exponent, and as long as it's a positive integer. So I could also make A 4 and B 4, or B 8 for that matter, but this is no calculator, so I'm going to try to keep the numbers small. And if I make these numbers bigger, then when I compare, those would be bigger, equally bigger, however I do it. So let's go with substituting this in. So looking at A, we have negative 2 times 2 to the power of 2. So that would be negative 4 to the power of 2. And when you have an even exponent, that would just be the same as 4 squared, because negative 4 times negative 4 is 16. And this would also equal 16. So you could rewrite it this way if you like, because it's an even exponent. All right, let's try B. We have negative 2 times 2. 2 times 2. So now we have negative 4 to the power of 4. So that's much larger unless it's negative. But again, because it's an even exponent, this would be the same thing as positive 4 to the 4th power, and it's going to be bigger. Now I don't have a calculator, but I know that this is bigger than that. So that one can't work. Let's keep going. C was 2 times 2 to the power of 2, so that's 4 squared. So A and C are actually equal to each other, no matter what you make A or B. This one's still bigger. Last. Okay, now this is a little different. Notice that this is separate. So the 2's out front, and A is to the power of 2 times B. So we have 2 to the power of 2 to the 4th. Okay, so that's 2 to the power of 2 times 2 times 2 times 2. That's 4 squared. So this is still smaller than that. 2 times 4 squared is still smaller, so you can see why we chose B as the greatest. Okay, let's keep going. 8, it said, which of the following is equivalent to A, x to A over B for all values of A? So it looks like they're asking us to rewrite it in this format, and I'm going to explain why B would be our answer. So you could say to yourself, what does a fractional exponent mean? Well, if I thought of it in the case of a number, like let's say 2 to the power of 4 over 3. That's the same as 2 to the 4th times 1/3, right? We can multiply exponents, and 4 times 1/3 is 4/3. So this is the same as the cubed root of 2 to the 4th. That's interesting, right? Because the cubed root of 2 to the 4th, what a cubed root means is if you have 3 of those, it would be able to come out. That makes sense. So I could actually simplify this. The cubed, this expression's actually equal to that expression, in a different form. So going back to our problem and kind of using this as a guide, we can say, oh, this is the same as x to the 2a times 1 over b. Just merely has been multiplied. And so that means this has to be the Bth's root of x to the 2a, which is exactly what b is. It's exactly why I've picked b, because those are equivalent. That's another way to write that. Now looking at 9, it says if x squared is equal to y cubed, for what values of z would this be equal? So I'm going, what they're asking you is, please solve for y to the 9th. So it's like, okay, well, I can multiply some more y's on this side, and whatever I multiply on this side, I got to multiply to that side. So if I multiply both sides by y to the 6th power, y to the 6, 7, 8, 9, I get x squared times y to the 6th is equal to y to the 9th. But notice how this is in terms of z. So you could substitute this back in, y to the 3, but you've really just had the left sides equal to the right side. So we need a different technique than maybe we've been using before. So let's think of this a different way. What could I do to both sides without multiplying something on both sides to get this to turn into that? Okay, so let's try a different strategy. If I cubed both sides, then that would not put y's on both sides. It would actually keep y's on the right and x's on the left. So if I cube both sides, now I get y to the 9th, and I get x to the 6th. So that's what they're saying here. They're saying y to the 9th is equal to this expression. We also know y to the 9th is equal to x to the 6th power. So we can set y to the 9th, we can substitute that in, x to the 3z is equal to x to the 6th. And notice these exponents have to be equal. So 6 has to equal 3z. If we divide 3 on both sides, z has to be 2, which is how I arrived at my answer of 2. Awesome. Let's do another. When I look at question number 10, I see bases, similar bases, and I like that because if they're the same base, I can compare them. All right, so we have 2x to the 3rd, k, and I notice these are the same, so I like that. I'm gonna add 2x on both sides, 2 to the power of x, all right, and on this side, I have k times 2 to the x, plus 1, 2 to the x, right? And then now I'm noticing I can distribute out this k plus 1. All right, so I'm going to distribute out this k plus 1. Oops, didn't do that. All right, I told you I was going to distribute out. Oh, what I can take out is a 2 to the power of x. So that's k plus 1. Right? Distribute out that to both terms. And that still has to equal this 2. So I could put it over here or here, it doesn't matter. 2 to the x plus 3. Now we said a minute ago, we know what it means when you add exponents. So this is the same as this, right? And so let's copy that down here. It looks like I can cancel the 2x on both sides. That I could divide both sides by 2x, and now it's getting a little cleaner. We have k plus 1 has to equal 2 to the 3rd power, which is 8. So when I subtract 1 on both sides, I get 7. And that is how I got 7. Let's take a look at 11. Now, similar to my example I gave you a minute ago, with merely I'm just kind of making up a number and showing you how I would break that down. This one's very similar. So this is saying the square root of x times the square root of x has to equal x to the a. So we can rewrite this as a fractional exponent. So this could be rewritten, excuse me, x to the power of 1/2 and we know that when exponents are next to each other, we can add them. And so there's actually one x here. So I could rewrite what's inside my square root sign as x 1 plus 1/2, square root of the whole thing. All right, so 1 plus 1/2 would be the same as 2/2 plus 1/2, which is x to the 3/2. So I'm almost done. Well, I can rewrite this one too, right? This would be x to the 3/2 1/2 equals x to the a. Now I've done it. So we said earlier, I can multiply exponents. So 3/2 times 1/2 would be 3/4. So x to the 3/4 has to equal x to the a, which must mean a has to be 3/4. And that's how I got my answer. If you got the same answer, good job. All right, 12. 12 says 2 square root of x plus 2 equals 3 square root of 2. So if x is greater than 0 in the equation, what's the value of x? Okay, so let's see if we can rewrite this. We have 2 x plus 2 to the power of 1/2 equals 3 2 to the 1/2. Well, this is not helping me because I don't have anything on both sides. So my suggestion is, if you can't multiply or divide something on both sides, do a function to both sides. So rewriting it didn't help. Let's do a function to both sides. Get rid of these square root signs by squaring both sides. Let's try that. So I get 4, because that's 2 times 2 squared, and then I get x plus 2 is equal to 3 squared would be 9, and the square root of 2 squared would just be plain old 2. So I get 18 is equal to 4 times x plus 2. So I'm getting close now. X plus 2 is equal to 9/2. So when you subtract 2 on both sides, you get x is equal to 9/2 minus 4/2, which is 5/2, also known, it's actually not rounding, that's the same as 2.5. So that's how I got 2.5. Check out the next video for the last 3 problems.